So let's start hypothesis test for one population mean when the sigma is known, right? We are now performing a real hypothesis test, and we have two cases here. The first one when the sigma is known, and we will see in other example when the sigma is unknown, the more realistic situation. When the sigma is known, this is less realistic situation. So what are the steps involved? There are 5 steps, and we are learning this via p-value approach of hypothesis testing. I told you in my earlier videos that there are 2 approaches for hypothesis test. One is called a p-value approach, and the other one is called a critical value approach. But we are first learning how to perform a hypothesis test for one population mean when the sigma is known by using a p-value approach. And there are some steps available for that, and let's see what are the steps. So what we do in the first step, we check the basic requirements. We need to see, we are about to perform a hypothesis test, so we need to see whether the basic requirements are met or not. Let's see what are the basic requirements. Number 1, we need to have a simple random sample. We have to have a simple random sample. Number 2, either the sample size is greater than 30 or the population is normally distributed. And if you remember from the chapter number 7, the previous chapter, the central limit theorem, this condition will guarantee that our sampling distribution is normally distributed, and this is guaranteed by central limit theorem. If you don't know what I'm talking about, please look at my previous video for this one. So we either require sample size, n stand for the sample size greater than 30, or the population is normally distributed. So once these basic conditions are met, we are good to go to perform a hypothesis test. What is the second step? In the second step, we find the null hypothesis, we find the alternative hypothesis, and we determine what is the significance level. At what significance level we plan to perform our hypothesis test, and that significance level is denoted by alpha. This is the third step. Fourth step. In the fourth step, we need to compute the sample test statistic, right? We need to compute the standardized sample test statistics, and fortunately we have a formula for that, and the formula is z equal to a sample mean minus the population mean divided by sigma over the square root of the sample size. That's how you compute this sample test statistic. This was the step number 3. What we do in step number 4, we determine the p-value. We compute. Once we have the test statistics from here, we can find the p-value. We can find this p-value by using a table, or we can use technology. What is the fifth step and the last step? If the p-value, now we compare this p-value we have obtained in the step number 4 with the significance level. We compare these two things, right? If the p-value is less than or equal to alpha, we reject the null hypothesis. And if the p-value is greater than alpha, then we say we are not in a position to reject the null hypothesis. Right? So again, if p-value is less than alpha, less than equal to alpha, we reject the null hypothesis. And if the p-value is greater than alpha, we fail to reject the null hypothesis. And we also try to interpret the result of the hypothesis testing in the given situation. So these are the 5 steps. It's very important that you know these 5 steps while we'll be doing this hypothesis testing. So let's see a real example. So here is the example. A fast food outlet claims that the mean waiting time in the line is less than 3.8 minutes. A random sample of 60 customers has a mean wait time or mean of 3.87 minutes with the population standard deviation of 0.6 minutes. If alpha is 5% or 0.05, test the fast food outlet's claim. We need to check this claim. So this is the hypothesis test we need to perform, and note that the population we are testing a claim about the population mean, and in the situation when the population standard deviation is known. And what we're going to do, we're going to use a p-value method. So there are some steps, and we will apply those steps one by one. Let's see these steps. So what is the first step? The step number one. Step one. In the first step, we check the basic requirement. What was the basic requirement? Number one, you need to have a random sample. You need to have a random sample. And number two, either n is greater than equal to 30 or x bar, or the x is normally distributed, or x or the population is normally distributed, or x, let me write it, or population is normally distributed, right? These are the, so look at these. This is our sample size is 60. Look at that. N is equal to a random sample of 60, right? So let's see these conditions one by one. Do we have a random sample? Let's check these conditions, whether these conditions are met or not. Let's see that. First, we have a random sample. Why? Look at that. A random sample of 60. This is the random sample, right? N is greater than 30. Look at our N. Our N is equal to 60, and that is definitely greater than 30. So both the condition for both the basic conditions are met. So we are good to perform a hypothesis test. Let's see step number two. Step number two. This was step one. I forgot to write. Step number two. In the second step, what we do, we write the null hypothesis, we write the alternative hypothesis. Here, look at that. What is our claim? Our claim is that the mean time is less than 3.8. And what is the opposite of that claim? What is the opposite of that claim? The opposite of that claim is mean time is greater than or equal to 3.8. Now one of them is a null hypothesis and the other one is an alternative hypothesis. Which one is which? We are going to see. Now remember, I told you that the null hypothesis never contains this less than symbol, never. So this must be our alternative hypothesis. H sub A, this is mu is less than 3.8. And if this one is our alternative hypothesis, so this must be with an equal sign, this must be our null hypothesis. Mu is equal to 3.8. We drop this greater than symbol. Why? Because the null hypothesis is always a statement of equality, right? And I will tell you the reason why this equality value will come handy. I will show you in a minute, right? So this is the null hypothesis, this is the alternative hypothesis, and we have found both the null and the alternative hypothesis. Now we decide the type of test. Note that our alternative hypothesis contains a less than symbol. Look at that. It implies that it's a left tail test. So it's a left tail test, right? So we have decided that it's a left tail test. Another thing we can see, alpha, the value of alpha. Alpha is equal to 0.05, right? So our significance level happened to be alpha, and that's a 5%, right? The 5% significance level we are testing this hypothesis, right? So now we have done the first step, we have done the second step. Now let's move to the third step. What is the step number 3? In step number 3, what we do, we compute the value of the test statistic, right? And for this we have a formula, Z equal to sample mean minus the population mean divided by the sigma over the square root of the sample size, right? We have all these values. We have the value of the sample mean. Let me show you. It's 3.7. This is the sample mean, right? So we have all these values available. We have a 3.7, the sample mean, and minus the population mean mu equals, so what was the mu value? I was telling you in the previously, I will show you. Look at that. Mu is equal to 3.8. That's the reason. That was the reason we take an equality sign, because now we are going to plug in here. So this is 3. Sorry for that. This was 3.7. This has to be 3.7 minus 3.8 divided by sigma was 0.6 over the square root of the sample size, which is 60. If I simplify this, all this stuff, this is a minus 0.1. It makes life better if I write it like this. Make our life little easier. In my practical experience shows that the students have difficulty when they have a fraction of a fraction, they have a difficulty. So if I write this expression, keep it, change it, and flip it, so there the students are easy. So I ask you to pause this video and come up with the answer comes out. So when I plug in these values in the calculator, so I get the value of the test statistics as minus 1.29. And what I have done, I have drawn a normal curve. Exactly in the middle, I have the mean value, the 0 in the middle, right? Now what I'm going to do, I'm going to locate this value in this particular curve. So minus 1.29 will be here, somewhere here, right? This is the value of our test statistic. So this is the value of test statistics, minus 1.29. Once you locate this value, you build a wall like this, and this area, the area to the left of the test statistic, if you remember, this is going to be our p-value, and this is the value which we are going to compute in the next step. This is the p-value, right? So that step number 3, or rather 4, sorry, step number 4, what we do in step number 4, we find the p-value. This is the area which I'm calling as the p-value. This is the value. So we compute in the step number 4, we compute the p-value, right? P-value can be found, and what I told you, what is the p-value? P-value is the area to the left of this test statistic. This is this p-value, and this can be found by using table or by using the calculator. Let me calculate this via table. So I already have opened this table. This is minus 1.29 and this is 0.09. So the value comes out to be 0.985. This is the value I'm talking about, 0.985. Let's go back. So the p-value comes out to be 0.0985. This is the value of this is our p-value corresponding to this test statistic, right? So we now start the last step, the final step, step number 5. What we do in the step number 5, we compare our p-value with the significance level. Now recall our p-value, we just did that, p-value, our p-value was equal to 0.0985 and our alpha value was 0.05, right? So this is the p-value and this is the value of alpha, the significance level. What we do in this 5th step, we compare a p-value with alpha, right? You can clearly see that you can compare that 0, 0, 0, 0, 9 and a 5. So this p-value is larger than alpha. So we note that the p-value is greater than alpha. So this thing implies that what is the conclusion? The conclusion is if the p-value is greater than alpha, we fail to reject. We fail to reject our claim. We fail to reject our null hypothesis. So what we are going to say? So we're going to say at 5% significance level, at 5% significance level, we fail to reject the claim that mean time is less than 3.8. 3.8. That's how we're going to interpret the result. So I have performed this complete hypothesis test for you guys, right? And I have shown you all the steps. I hope you are able to understand that. Thanks for watching.